Okay, so let's now get into the AWS code deploy. So code deploy is obviously going to be a better focus on the DevOps professional exam, but for a solution architect professional exam, you absolutely need to know how code deploy works for deploying to EC2, Autoscaling group, Elastic Container Service, and even the Lambda. So this is what this lecture is going to cover. So code deploy is going to help us deploy our application to, for example, many EC2 instances. The idea is that they are all on version 1 and we want to somehow migrate them to version 2 by deploying new version of the code. So then these instances are not managed by Elastic Beanstalk. They are running the DevOps that could deploy agents, and this code deploy agent is going to be one helping these instances move on to the next version. So there are several ways to do deployments on AWS. That is Ansible, Terraform, Ceph, and Puppet, etc., etc., and then even Elastic Beanstalk. But we can use managed service, code deploy. So code deploy could deploy to this specifically on AWS. And why? Because code deploy has integrations with EC2, auto scaling groups, Elastic Container Service, and Lambda. So now let's have a deeper look at how code deploy works for each and every one of these functions and services. So first one is EC2. So we define how we want to deploy the application in the like in the app named appspec.yml plus our deployment strategy application using appspec.yml and deployment strategy. And the deployment strategy could be how fast we want the rollout to be. Is it all at once? Is it gradual? Is it rolling? Is rolling with batch? It is immutable? Is it blue green? So all of these, and this is not just the focus of this, we are just understanding how it happens at a high level. It will do in-place updates to your fleet of EC2 instances. It doesn't create new EC2 no new EC2 instances. We can define hooks on the EC2 instances to verify the deployment is working great after its deployment phase. Okay, so the idea for it is like one example is called half at a time, and we have 4 EC2 instances and they are V1 and half of them are going to be taken offline. So we have 2 of them gone offline and then 2 of them are kept on version 1. So right now we are serving half the traffic. Okay, so we may have more load onto these 2 remaining EC2 instances, but because the other ones have been taken offline, then they can be upgraded to version 2, and so now we are running half of the EC2 instances on version 2 and half the instances on version 1. Then we'll take the other half, will take it down, and code deploy will do this for you obviously, and then the instances will be upgraded to version 2, and we have successfully performed a half at a time code deploy deployments into the EC2. So there are different strategies that the code deploy can do for EC2, but just remember this one, it is very simple and it gives you an idea of the process. In this example, this is in place updates. So the EC2 instance is going to be changed to take down the version 1 application in some way and make the version 2 application appear right after. Okay, now let's step up a little bit and talk about code deploy to your auto scaling groups. So we have 2 kinds of updates to your auto scaling groups. The first one is in place updates, where you update the current existing EC2 instances in your auto scaling group. So this is very similar to what we have seen from the past slide, and the instances that get created by an auto scaling group will also get automated deployment. So if your auto scaling group does a scale out, so it creates new EC2 instances during code deploy deployment, and code deploy will also deploy to the new EC2 instances. So this is one way, and I'm not here representing it because we have seen in the past slide, but then there is there is a blue or green deployments, and in that case a new auto scaling group is created. The settings are copied and then the instances will be transferred from one auto scaling group to another auto scaling group, and we can choose how long to keep the old instances, and we must be using an elastic load balancer for these kind of deployment. So I've simplified it, but here's the example. So ELB is serving traffic and we currently have an auto scaling group auto scaling group that has EC2 instances that are launched using the launch template version 1. Code deploy will deploy your application into these instances, and in case your auto scaling group starts adding more EC2 instances, so as we scale out for our auto scaling group, code deploy here is the smart enough to start deploying the application to the instances. But as soon as we initiate the deployment for getting into version 2, we are getting into a blue-green deployment, and EC2 instances are going to be created in another auto scaling group. But in this example, I just put it under the same name, and it doesn't really matter, and they get transferred over to the old auto scaling group. And now we have both EC2 instances running, the version 2 and the version 1. So code deploy has to deploy the application to these new EC2 instances running the version 2 version, and then ELB is going to be serving both versions at the same time. And if everything looks fine, then at the some point a code deploy is going to remove the old instances and the deployment will have happened. So what we can remember out of this deployment is that if we are doing blue or green deployment with an auto scaling group, new EC2 instances are created, and so they are clean, and then we just create the application version 2. So these new EC2 instances, and that may be easier than shutting down the version 1 instance, version 1 application, and creating the version 2 application on the same instance. So it's up to you, up to your requirements, but at least you have seen the blue or green deployment on the auto scaling group. Now let's talk about the Lambda. So code deploy can deploy to AWS Lambda, and you need to know this. And what it will do is that it will use the traffic sifting feature of your Lambda alias. You can also define a pre and post traffic hook Lambda functions that will help you validate the deployment itself. And I'll show you in a diagram right now, and you can also get easy and automated rollbacks using a CloudWatch alarm that you would set up. And finally, if you are using the serverless application model framework SAM, then in case you deploy a new Lambda version through SAM, it will naturally use code deploy for doing the deployment, and that is very important to remember. So let's say go through a concrete example. We have a Lambda here alias, okay, and it's running version 1 Lambda function. So we are going to trigger code deploy. Maybe it's our CI/CD that's going to trigger code deploy, and code deploy needs to create the version 2 function of our Lambda. And right now it's going to be in the alias, but we have 0%, so no traffic is going to our version 2. Code deploy will then run if we have specified it at a Lambda function, which is another Lambda function, and that Lambda function is called the pre-traffic hook. So if you will not be able to see, you will be able to see that now. Pre-traffic hook and the post-traffic hook 2 function, and run test is there being actually hidden by my view. So we have the pre-traffic hook Lambda function, and its role is to run some test on your version 2 Lambda function to make sure that it behaves properly. And if it does behave properly and it passes the test, then code deploy will start using the Lambda alias traffic sifting feature to start sifting traffic between your version 1 function and your version 2 function. So now your version 2 function is going to start receiving traffic. You can also set up a CloudWatch alarm, and is going to monitor maybe some metrics around your Lambda function or other things, such as if the CloudWatch alarm takes off, then code deploy will automatically roll back your deployment, and then you will be back with just version 1 function. So finally, once the traffic fix shifting has done and is finished, we can run a post traffic hook, and is one more Lambda function that we have to define optionally, that we'll run some test after all the traffic has been shifted on the version 2 Lambda function. And if everything passes, then our version 1 Lambda function is gone, and the Lambda alias will only serve the version 2 Lambda function. And that's it. It's fairly simple. It looks like the same from before, but here you have to remember we are using the traffic shifting feature of the Lambda alias, and also we have Lambda functions for pre-traffic hook and post-traffic hook to run some test during our deployments. Finally, we have code deploy into ECS, and This is supported again with the blue or green deployments for Amazon ECS and AWS Fargate, and the setup is going to be done within the Elastic Container Service definition. So it's not something you can do currently from the code deploy console. You have to go into the Elastic Container Service and define it there. And the idea is that a new task set will be created, and then the traffic will be rerouted to the new task sets. And then after the deployment has been done, code deploy will check if everything is stable for X number of minutes, and then if it is, then old task set is going to be terminated. And so you have some time to notice issues, and if you need to. So now let's go through this diagram again. So application answer, application here, the ECS service is going to be launching here the ECS task and using the test definition number one, and then the code deploy is going to say, hey, I want to do a deployment onto Elastic Container Service, and you need to upgrade to a new task version, task definition. So there's going to be a blue or green deployment and traffic shifting feature that will happen. And so ECS service itself will start launching a new task sets using test definition number two, and that will be linked into the application balancer. And then code deploy will make sure that there is a traffic shifting feature happening. So this is a screenshot from the code deploy. So this is a screenshot from code deploy itself, and as you can see on the bottom right, there's a traffic shifting progress, and which is what the original instance is. Original instances right now have 60%, and for the traffic and the replacement instances have 40% of the traffic. And so the traffic will be shifted gradually over time, and then after everything has been shifted, they will check for stability and for maybe 5 minutes, and then if everything is stable, the old task definition, the task definition number one, and the task set associated with the task definition will be deleted, and code deploy will have successfully performed a deployment onto ECS. So as you can see, the ideas are very similar. It's just that every single services has its quirks. So code deploy uses service features that are going to be native to that service, but the idea remains the same here. And so if you do understand these four kind of deployments, and you are all set for your solution architect professional exam. And all right, that's it. I will see you in the next one.